Now that you all are experts in naming ionic compounds and writing their formulas, we're going to step it up a notch, and now we're going to talk about naming and writing formulas for acids. As it turns out, this is going to be really similar to what you've done before, so hopefully it shouldn't be too big of a step. What is an acid? I know you've all heard of one. You might have some images of what an acid is, but simply an acid is just a hydrogen with some kind of anion. Remember, that's a negatively charged ion. It's just a hydrogen with something negative attached to it, okay? Um, Acids are technically what we call molecular compounds, and molecular means they've got its nonmetals bonding together. But since an acid ends up following a lot of the same rules as the ionic ones, I'm teaching it right after ionic, okay? So you can think of the hydrogen, because it forms that +1, it's kind of sort of acting like a metal, like one of those group 1 metals, which is why they put hydrogen over there on the left side in group 1, even though it's a nonmetal. So that hydrogen is kind of acting like a metal, giving away its electron. And so it's going to bond with a negative thing in the exact same way that the ionic and polyatomic ones did. Okay, there are two kinds of acids. One that just is a hydrogen with something on the periodic table. Another one is a hydrogen with polyatomic ion. Let's start with the acids that are just a hydrogen with something on the periodic table. Remember, our nonmetals are located in the upper right-hand corner of the periodic table. So this is essentially things from group 6 or 7, because the noble gases are in group 8 and they don't like to bond, right? And so basically hydrogen is going to be combined with one of our halogens or something from group 6 or group 7 or maybe group 5, and that's going to be an acid. And so here are two examples. Notice we have one hydrogen and one fluorine, because +1 -1. We got one hydrogen and one chlorine, again, +1 -1. But if we wanted to name this, any of these types of acids are going to start with hydro, okay? And then they're going to take the anion, and it's going to be like before it would be fluoride. Well, it's going to be ic. So this is hydrofluoric acid, okay? HCl would be hydrochloric acid. HBr would be hydrobromic acid, okay? So there you go. They always start with a hydro, and the anion's name gets changed to ic, okay? That is how we do those. If you do have a polyatomic ion, then it's going to be a little bit different. The name is based off of the ion, okay? And so we've got some different ending rules here. So let's address those as we go. HNO3, we know there's hydrogen, and NO3, if you look it up in our chart, is nitrate. So according to our rules here, nitrate ends in ate, so that's going to become ic. This is nitric acid. Notice, big, huge thing here. No hydro. We only have hydro with the name when we're here working off of our periodic table. When it's hydrogen and something on the periodic table, we use hydro. Hydrochloric, hydrophobic, hydrobromic, all these different things. When it's hydrogen and something off of our chart, there's no hydro in the name, and that's the big difference. Okay, so it's hydrogen with nitrate, so nitrate becomes nitric. So this is nitric acid. Let's do another one. Here we go. This is a polyatomic ion. It's iodite. Looking at my ending rules, which you should have written down in your notebook, because these are going to be really, really important. Let's see. Ite. Ite becomes us. So iodite becomes iodus. So then we're iodus acid. I know it's kind of weird sounding. Okay. One more. Here we go. Again, we're with something off of the polyatomic ion list, and so we're going to be looking up its name. And so carbide, let's look at my rules. Ide becomes ic. This is going to be carbic acid. Okay, and remember, no hydro, because these things are off your polyatomic ion sheet. Notice this is really, really similar to naming ionic compounds, okay? So the only thing that's different, instead of starting with sodium or lithium or iron, it's starting with hydrogen. All of them start with hydrogen. Sometimes we say hydro when the thing is off the periodic table, and sometimes we don't say hydro when it's off of your polyatomic ion sheet. Now we're going to do the opposite. If you're given the name and you have to write the formula, it's same as ionic. We're going to try to balance out those plus and minus charges. Okay, so hydrobromic acid. Ooh, okay. That means I know I'm going to start with a hydrogen because all acids do. And I know that this bromic is referring to bromine off the periodic table because of the hydro. This means I'm working straight off of my periodic table here, not a polyatomic ion. Whenever you see hydro, you know no polyatomic ion. Okay, and Br is a halogen. So it always has a charge of -1. So plus and -1 cancel out. So it's just HBr. Hydrosulfuric acid, again, that's a sign that I'm not on my polyatomic ion sheet. I'm just off of my periodic table. So sulfuric would come from sulfur. Hydrogen, group 1, charge of +1. Sulfur is in group 6, has a charge of -2. So you're going to need another hydrogen. You're going to need 2 total hydrogens to balance out that -2 sulfur. So the formula would be H2S. Let's try some with some polyatomics now. Cyanic. Notice I don't see a hydro, so that lets me know, oh, I'm on my orange sheet. And so I go and I look it up, and I see that cyanic is from cyanide acid, was from the cyanide ion, which is CN, it has a charge of -1, and H is +1, +1, -1 cancel out, so it's HCN. Phosphorus acid. Okay, again, no hydro there, so I know I'm going off of my sheet. Phosphus, I got to look back to my ending rules. My ending rules means it used to be phosphite, so I look it up, and phosphite is PO3 and has a charge of -3. H has a charge of +1, so I'm going to need 3 +1 hydrogens to balance out that phosphite. So the formula would be H3PO3. Okay, so that is how you name and formula write for acids. One of the main things that you will have to know and remember are these naming rules right here. Ate becomes ick, ide becomes ick, ITE becomes OUS. If you see hydro, you know you're working off the periodic table. The anion is on the periodic table. If you don't see hydro, then you know the thing is from your special polyatomic ion sheet.